Correlation and regression, page 1. So first thing we see here is that in positive correlation, we have basically a positive slope or gradient. You can see that the data kind of goes up as you go from left to right. And they just basically say the dependent variable, which is the y-axis, goes up as the independent variable increases. Okay, so positive gradient or positive slope is positive correlation, so easy to remember. Now, in 5D1, they show you a few different diagrams, and basically they want you to say whether or not it's positive or negative correlation, and if it's linear or nonlinear, and if it's perfect, strong, moderate, weak, or none. Now, perfect, strong, moderate, weak, or none is just, these are not quantitative, so you're just going to kind of guess. Okay, so perfect correlation would be like they're really in a line, and no correlation would be they're not in a line. Okay, and linear and nonlinear would be, linear would be they're in a line, and nonlinear would be, well, they're in some kind of pattern, but not a line. Okay, all right. So let's look at A. So it looks like A is, positive linear correlation because it's a line, right? So I would say it's positive. I would say it's linear. And I wouldn't say it's perfect, but it looks pretty strong, right? Strong. Okay. Let's look at, let's see, do we have any other positive correlation? Look at that one. Oops. That one also looks positive, right? Except maybe not so strong. So we'll say positive, linear, and maybe just moderate. Okay? Anything else look positive? Maybe this one here, but it's pretty weak, right? It may be a line, but we'll say it's positive, linear, and maybe weak. Okay? None of the others look positive. Let's see if there's any negative. So let's see, that looks negative, right? That looks negative, and by negative I mean it goes down as you go from left to right. That looks negative, although not very strong. Okay, so let's say that this one is negative, linear, and maybe moderate. This one would be negative, linear, and it looks very nice, right? So maybe we'll say perfect. And this one would be negative, linear, and kind of weak, I guess. Maybe weak or moderate. It's kind of hard to say. And look at this one. This one looks perfectly correlated to something, but it's not a line. So we'll say nonlinear, and we'll say it's perfect correlation. And then what about this mess here? I can't say that's positive, I can't say it's negative, I can't say if it's linear. So basically we'll say none. No correlation at all. Okay, that we can see at least. Alright, number 2. For each set of data, plot the points on a scatter diagram and describe the type of correlation. Okay, so let's see. We'll take data set A first. And they give us X and Y, and so we're going to use our graph paper here to graph these points. So I'm going to number my X and Y axis about from 0 to 50 for each one of these axes. And I'm going to jump basically 5 units for every 2 to make it fit here. Let's see, we'll start graphing each of these pairs then. So we'll start with 28, 24. That would be about 28, 24. It'd be about there, I think. Okay. 30, 36. That would be about there. 25, 30 would be about there. Remember, the first coordinate is the x coordinate. 35, 40 19 comma 25, 19 comma 25, 38 comma 34, 25 comma 28, 33 comma 34, 41 comma 44, 22 comma 23, and 35 comma 37, and 44 comma 45. Okay, about like that then. And let's see, what kind of correlation would that be? Well, I would say it's positive correlation, and linear, and doesn't look strong maybe, but at least moderate, right? You can tell that's approaching a line. Okay, and let's do B then. So B has much smaller values, from 0 to 20 about. Let's mark our axes. See if we can just use our axes marks from this one. Isn't technology wonderful? How's that? Okay, and then maybe like the same, we could do it from here too. Y coordinates. Okay. All right, and let's put some additional marks here because these numbers actually go down to almost a 0. Okay, so the first pair would be 3 comma 16, which would be about there. And then 7 comma 11, which would be about there. And then 7 comma 12, which is, wow, it's almost the same place. And 11 comma 9, about there. 16 comma 6, 16 comma 6, 15 comma 7, 17 comma 3, and 17 comma 9, and 18 comma 5, and 20 comma 6, okay. That looks like negative correlation to me. It's a negative gradient. So we would say negative, linear, and I don't know, you'd say moderate or maybe weak. It's kind of hard to say. Okay, we're going to learn later that you can say it exactly if you use the calculator and calculate a coefficient, which describes how correlated it is. But if you don't do that, you're just guessing. So, there's not going to be too many problems like this on the test where it's hard to give you an exact grade. Okay, that's it for page 1.